I was invited to talk about the way that ECMWF does innovation for, can you see my screen? Can you see it in presentation mode?
We can see. Yes.
Okay, so you can see me moving my slide. Perfect. So this slide talks about what I want to touch upon with examples from our activities. I want to talk about innovation in the content of material for climate services, on delivery, and on outreach training and user support. Just to tell you where I'm coming from, I represent the Copernicus Climate Change Service. It's one of 3 services that the ECMWF contributes to. Copernicus is the European program for Earth system observations, focusing on satellites, but not exclusively so, and has 6 services attached to it. ECMWF runs the Climate Change Service and Atmospheric Monitoring Service. I work for the Climate Change Service, and there I lead the activities on climate predictions and projections. Firstly, about the content, as I said, we tried to be innovative in our approach to things, and we have developed new content based on observations in many cases, creating climate data records and essential climate variables, as well as global products based on observations. But I think our strength lies more in combining observations with models. So we have put effort in analysis, global and regional. We have 2 regional analysis for areas in the Northern Hemisphere. Both of which either have or will very soon have near real-time components, which is really important as far as I understand from the perspective of regional climate services to enable near real-time monitoring. We also have models that are put into prediction mode, so into looking into the future. So seasonal forecast is again one of the things that you would probably have heard me speak about in the past. We use several models. We output high frequency of data, and we have an operational schedule. We have also done work on multi-year climate predictions using the decadal predictions set up by the IPCC and CMIP project. There again, the big change, and even a change to some of the WMO infrastructure available for these purposes, the data is freely accessible and it comes with very significant user support. We also provide access to climate projections, global and regional, currently just as it comes pretty much from the Earth System Grid Federation, but also we are preparing an interactive atlas inspired by, based heavily on the current assessment, IPCC assessment atlas. We've used much of this data from seasonal predictions and climate projections in sectoral climate impact indicators that you can find on our website relatively straightforwardly. I'm trying to advance and I see that I can't. Okay, from a technical perspective, we have a technical interface we call the Climate Data Store to allow people access to our data. It is online, it's open and free service. It allows people to browse a catalog, users to browse a catalog and search through it, and to download the data, as well as build applications based on the data, because the purpose of this is primarily to allow not just relatively uniform access to the data, but also the capability to process that data close to its source. It is a distributed system with data suppliers who either send us data or we just act as brokers. But the essential thing is that it comes to the user in a straightforward fashion. We have used this in applications for individual sectors. Again, if you haven't heard me speak about these before, you can very easily find this on our website. Lastly, and probably very importantly, is the user support and training. There's a variety of ways to interact with the service, to get information self-service, to have a knowledge base. There are workshops in which we provide information about how to use our product. There's monitoring of user requirements, but there's also direct response to individual user requests. There's a large variety of training activities. Again, some of you would have been part of some of them. The RCC network is now getting more and more involved with our training programs. And we also prepare using Jupyter notebooks. Somebody mentioned them before. I wanted to close by pointing out that lots of challenges remain. In terms of content, yes, methodologies have been developed, and we have been one of the big players in developing methodologies to put observations and model data into products, into information, extract information from climate services. However, the fundamental tools and ingredients still need further improvement. So better models are needed, and these are not necessarily funded in the same way as climate services when it comes to it. Better design of these tools to serve climate services. Those who use climate projections, you may have noticed that the CIMIP intercomparison project is not really designed for climate services. It's not designed to look at the possible range of outcomes, to look at all the uncertainties that you might need to take into account for adaptation to climate change impacts. I'm not going to dwell on the remaining challenges on delivery. We've heard several people present solutions. I would still argue that there is a lot to do, because data from climate, about climate, and from sources that represent the climate is very heterogeneous. So interoperability is not straightforward, and solutions for this will be forever needed. But in terms of amounts, the data is becoming larger and larger. Of course, you're talking about satellite observations, which are immense data sets, but also stuff that comes out of models are increasing resolution, and that's going to become very hard to use. And finally, given the large diversity of users, interests, and capabilities, the tailoring of training and user support is important and remains a challenge. Thank you.